we are talking about fractals. So fractals are pretty cool. Basically, shapes that have self-similarity. In other words, it's the same shape within itself. So we're going to start with an easy fractal. It's called the Koch curve. And the way you make a fractal, you can't just go out and draw a fractal. All right, you have to do iteration by iteration by iteration. Because this is the first iteration, second, third. Okay, this is how you create a fractal. And you're going to do this an infinite number of times to get the actual fractal. So notice the pattern here. So I just started with a straight line from point A to point B. Not a big deal. Now what you do, every time you see a straight segment, you're going to divide it up into thirds, and you're going to replace the middle segment with two equal pieces. All right? So like the total length of this one, and I'll just write over here. So the length here, and I'm going to call this L0. In other words, L naught. So L naught is 18. So if you count up the squares, we have 18. The length here, on the other hand, for the first iteration, well, if I count up the squares, so I have 6 squares. On each one, I have 6. So you do 6 times 4, which is 24. Continue the pattern here. So again, every time I see a straight segment on the next iteration, I'm going to take out that middle third and replace it with 2 equal segments so that I have 4 equal segments. Just like this whole thing, I have 1, 2, 3, 4 equal segments. So I'm going to take this section, I replace it, take out the middle third, put 2 equal segments, so I have 4 equal segments. Each one of these is 2 units long. And I do the same thing for every other straight line I see. So this straight line, again, take out the middle third, replace it with 2 equal segments. Do it for this line, I'm going to replace it. This line right here, I'm going to replace it. So now let's think about the length on this one. So iteration n equals 2, so I'm just going to call it L2 for my new length here. Well, let's see, for the old one, so 6, well, now it becomes 8. So each one of these is now becomes 8. And I have 4. 1, 2, 3, 4. So 4 times 8 will get you 32. And so to get the true fractal, and I'm not a very good artist here, this is just an approximation. But I mean, if I did this an infinite number of times, that's how I get the true fractal. I have to do it an infinite number of times. And you get this nice weird looking curve. It'll do something like this. Oh, that's terrible. Let me try it a little better here. You know what? Just go online and take a look at it because this is not working out. But it would look something like this. If you actually did it, it would look something like that. Okay, that's a horrible, horrible version of a Koch curve, but it looks something like that. Okay, like I said, go online and see what it really looks like. It looks a lot more symmetrical than that. But this would be for an infinite number. So n equals infinity. Okay, that's an infinite number of iterations. So again, each time you do these steps, each time you take a segment, replace it with the self copy. So replace each segment with a copy of the entire thing is what we're doing. Every time, replace the segment with a copy of the entire thing. That is a fractal. And so these are the iterations. So those are the different iterations. So again, for an infinite number of iterations, you get a nice smooth curve. Well, the mathematical definition of smooth, not necessarily. This was actually created to make it very difficult for mathematicians to precisely say what it is. But it's going to look smooth. I'll say that. It's going to look smooth. All right, so that is a fractal. And one of the questions is, well, how long do I know is it going to be for a number of iterations? Like, suppose I did a third iteration. Well, I know for the second, okay, so for n equals 2, I know the total length is going to be 32. Now for the third one, well, I know it's going to be longer because it gets longer every time. And it doesn't get longer by a smaller amount. It gets longer by a larger amount. I mean, look at your differences here. So this went from 18 to 24. Well, that's a difference of 6. So we had to add 6. And then from here to here, well, now I'm adding 8. So every time you have an iteration, notice it gets longer by a larger amount. In other words, we call that diverges. Converges means that it gets longer, but by a smaller amount. And so think about that. There's a question on the homework. Think about that when you talk about what the length is going to be for an infinite number. Because it's going to sound crazy, but just go with the math. It's an interesting result. So how do we get the length for any given number of iterations? Well, let's think about it. We need two things. First of all, I need to know the scale. How long is each piece? And I'm just going to look at the simple one, n equals 1. How long is each piece? So we call that a scale. In other words, that's going to be your segment length. So I need to know that. And then I also need to know the number of segments. So number of segments. With that information, I can figure out the total length. I just have to multiply the two together. So for scale, we're just going to call it S. So S equals, well, let's look at the pattern here. I started out with 18. Okay. So my total length started out with 18. I'll call that L naught. Now, every time I'm dividing it by 3, I'm dividing it by 3 again and again and again. But now here's the thing. I'm dividing by 3. But it's not just 3. It's actually 3 to the n power. Because here I take 18. Well, if I divide 18 by 3, I get 6. If I take 6 divided by 3, I get 2. So, I mean, each step I'm dividing by 3. But if I start from the original, I'm dividing by 3 to the n power. Okay, so like for the next step, okay, 3 to the 1 is just 3. 18 divided by 3 gets you 6. For the next step, 3 squared. 3 squared is 9. 18 divided by 9 will get you 2. All right, so it's going to be the original length for n naught, or in this case we're calling L naught, so the original length, divided by 3 to the n power. N is the number of iterations. So that's the segment length. Now I need to know how many segments are there. How many segments are there? So every time I'm taking the number of segments and I'm multiplying it by 4. Every time I'm multiplying by 4. So if I'm multiplying by 4 every time, then it's just going to be 4 to the n power. So for number of segments, we use m. And that's going to be 4 to the n power. So now I put that together. Then I could say total length at n iterations. Well, that's going to simply be L equals, well, put it together here. So I have L naught. That's the original length when you very first start out with just that straight line. Times, well, let's see, 3n is on the bottom, 4n is on top. So 4 to the n divided by 3 to the n. So for any given number of iterations, I can find the actual length of this curve. And again, on the homework assignment, I'm going to ask you a question. It's going to say, how long is this curve for an infinite number of iterations? And again, your answer is going to sound strange, but it's actually true.